Hello friends, welcome to Susan and John MathTube. Today we are going to continue the topic convergence and divergence. And the first thing we're going to do today is work out a few special questions on D'Alembert's ratio test. And at the end of the video, we will learn a new test. It's called higher ratio test, the RAPS test. And you'll understand sometimes we will be helpless even with D'Alembert's ratio test, and in such cases, the RAPS test will be just perfect. So let's start. Test for convergence, the series. Okay, we have a continued product here. In the sense, all these things will appear in the next term. And all these quantities will be in the third, fourth, fifth, etc., etc., etc. So, as always, let's give it a name. Let the given series be sigma un. And now we have to extract un, and to write un, you have to understand one thing. The third term contains all the quantities in the second term, and the fourth term contains all the quantities in the third term. Anyway, it's a continued product. So we are going to write 1 into 2 into 3 into 4 into dot 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 up to n. It's very easy to understand that because in the second term you can see 1 into 2. In the third term you can see 1 into 2 into 3. In the fourth term it is 1 into 2 into 3 into 4. So it's nothing but 1 into 2 into 3 into 4 into dot 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 up to n. Now let's check the denominator. Clearly they are made up of odd numbers. So 1 into 3 and then 1 into 3 into 5, 1 into 3 into 5 into 7, etc., etc. So if you want you can apply the trick. 1 and 3, the difference is 2. So I write 2n. Now I insert n is equal to 1. Yeah, so I end up with 2n minus 1. And if you have any confusion with these things, you can check the first video in convergence and divergence, where I explain this method very clearly. Okay, now we want un plus 1. It's very easy to write un plus 1. You have to write all these things and then the next term. So replace n with n plus 1, you get the last one, and you replace n with n plus 1, but be a bit careful, and you get this. Now, do you remember the condition for ratio test? Yeah, the limit. This is exactly what we have to find. Anyway, we have un and un plus 1. So I'll just plug in un and un plus 1, and everything is going to get cancelled. Yeah, and it simplifies and we get, and now I'm sure that you're very good in these limits. So take n outside, then you can cancel, and I hope you remember n tends to infinity means 1 by n tends to 0. So we have the limit value as 1 by 2, and if you remember the condition for ratio test, you'll understand that the series is convergent. If you are not good with the conditions of D'Alembert's ratio test, then pause the video right now and watch the starting video of ratio test. Okay, let's move ahead. And okay, so we have the second question over here. Test for convergence 1 plus 1 into 3 by 3 factorial plus 1 into 3 into 5 by 5 factorial plus dot dot dot. Clearly another case of continued product. So as usual, we'll give it a name sigma un. And then we go for the general term. And it's easy to write the general term like we did before. But the denominator is 1 factorial, 3 factorial, etc. You apply the trick and you will get. And be extra careful when you write the n plus first term. And then, as usual, the limit. But before we start, I'll give you a small hint about how to deal with factorials. For example, 10 factorial means 10 into 9 into 8 into dot 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 up to 1. And 9 factorial means it's like 9 into 8 into 7 into dot 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 up to 1. So, what I'm trying to convince you here is 10 factorial can be written as 10 into 9, and if you want to stop here, you just put 1 factorial. Or 10 factorial can be written as 10 into 9 into 8 into, I want to stop here. That's it. So in general, if you have n factorial, you can simplify n, n minus 1, n minus 2. If you feel like stopping it over here, just put factorial. Now let's go back to the limit. So just plug in un and un plus 1 from here. Simplify. Now look at this. We have two factorials. 2n minus 1 factorial and 2n plus 1 factorial. Always remember, in factorial simplification, you have to manipulate the bigger quantity. It's clear that 2n plus 1 is bigger than 2n minus 1. So I'm going to write 2n plus 1 factorial as 2n plus 1 and then 2n and then 2n minus 1, and I'm going to stop because this is exactly the term I have in the numerator. So we have limit n tends to infinity 1 by 2n, and that's 0, and 0 is less than 1, and you know the condition. If the limit is less than 1, then converge. Okay, now my friends, we move on to something very, very important. What will you do if you get a problem related to continued product and if the ratio test fails? The ratio test will fail if the limit value is equal to 1. Earlier we did one question similar to this, but the general term was not a continued product, so we were able to apply the limit comparison test. You can check the previous video where we tried this. Now my question is, let's suppose we have a question related to continued product and D'Alembert's ratio test fails. Okay, in such cases, Raps test will be the best option. So the test goes like this. Let sigma un be a positive term series. And I hope you remember, positive term means all the terms will be positive and it will either converge or diverge. And this is the condition. It looks weird. I know it looks weird, but this is the condition. And here goes the conclusion. L greater than 1, it is convergent. L less than 1, it is divergent. And L equal to 1, the test fails. I forgot to ask you the most important question. Do you have a pen and a paper? Yeah. If not, get one and note all these things. And let's go to the last problem and the first problem in Raps test. So here it goes. Test for convergence. You have a function given as in series form. So as usual, let sigma un be the given series. Then I extracted the general term and as always un plus 1. Since the question is related to a continued product, I'm going to apply ratio test, not higher ratio test. I'm going to apply D'Alembert's ratio test. So as always, the limit n tends to infinity un plus 1 by un. So just plug in the un value and un plus value, simplify, simplify, apply the limits, and we get x by 4. We have done problems like this, so many problems. Okay, so by D'Alembert's ratio test, this is exactly what we get. If it is less than 1, the series will converge, and if it is greater than 1, it will diverge, and we won't be able to make any conclusion, or we say the test fails if x by 4 equal to 1. But we cannot leave the answer as such. So what we do is we're going to analyze. So we're going to analyze the condition x by 4 is equal to 1. So now look at this. Our question is related to a continued product and factorial. So we cannot apply, yeah, exactly. We cannot apply the limit comparison test. So the only option we have now is RAPS test. And I hope you remember the criteria for RAPS test. That is limit n tends to infinity n into un by un plus 1 minus 1. So this is the criteria, and for that purpose I extracted un plus 1 by un from the previous steps. You can you can check a few minutes back. I have this expression, and from here I'll be able to write un by un plus 1. I'll repeat, we have this in the previous steps, and once you have un plus 1 by un, you can just take the reciprocal and have this. Now the condition, that is, so you put x equal to 4, simplify, and then the condition, just plug in the value, simplify, again simplify, and finally the limit. Okay, now you can pause the video, or you can go to the first part of the video and find the condition for RAPS test. So it's less than 1. So the conclusion is our series will be divergent if x by 4 is equal to 1. So that's it. So now we can cancel this no conclusion and then write this. I'll repeat. I hope it's clear. Let's combine the last two and make it. Okay, that's it, my friends. This is how we apply RAPS test, and now I think you have a clear idea with the test. Anyway, in the next video I'll be back with more problems in convergence and divergence, and we'll be discussing the last two tests for positive term series, the integral test and the radical test. Till then, bye.